Cool, here we go. Well, today we're going to talk a little bit about two charts that we have here about muscle types and ATP types. So first we're going to...
ATP utilization?
Yeah, ATP utilization types. We have 4 of them, and then we have 3 different types of muscles. Let's begin with muscle types. So here we have 3 different types known as slow 1, fast 2A, and fast 2X, which in animals is actually known as fast 2B, but it's a little bit different for us humans, and so we decided to rename it into fast 2X. So we have a couple different categories for them to fit in. First we'll start with ATPase speed. So that's the speed that ATPase is used to separate or for hydrolysis to happen. So for slow 1A, it's slow, and for these it's fast.
Which one is the fastest?
Fastest is fast 2X. Now typically this will be the slowest on this side, and this will be the fastest amount. So, and for the sizes of these muscles, slow 1 actually tends to be rather small, while fast 2A tends to be about a medium size comparatively, and fast 2X are large muscles. And these, the slow 1A tend to have lots of mitochondria, lots of it. Same for fast 2A. They tend to have a lot of mitochondria to power them, while fast 2X tends to actually have none at all. It doesn't require mitochondria's presence. While myoglobin here tends to have a lot of blood supply for the slow 1A and for fast 2A. While over here you have a low blood supply. So here you have lots of blood in slow 1 and in fast 2A. While in fast 2X you tend to have a low blood count or not a lot. While in their colors, these tend to be more red because of the amounts of myoglobin that are inside the muscle, changing the color to red. While fast 2X, having very low amounts, tends to be more of a whitish color, like white chicken breast and the like. And blood?
Mm-hmm.
1 second. Yeah. Mix these up a little. So these tend to have a rich blood supply. As we talked about here, kind of mix up these sections a little bit, but we can fix that real quick. Myoglobin is the color of blood.
You can skip the back part.
Yeah, so myoglobin here tends to have, this part has myoglobin.
Mm-hmm.
Same for here, it has myoglobin. While this one has no myoglobin.
Okay.
And we can skip this part here.
Mm-hmm.
We need to talk about this and the process of how it uses the energy, or it pumps out energy. Is here these have a type of energy known as oxidative phosphorylation. And since this is long, I'm just going to say it's the same here for fast 2A, but not for fast 2X. Fast 2X tends to use glycolysis.
What is glycolysis?
Glycolysis uses glucose and it breaks it down to be able to create low amounts of ATP for us to use. And while these two here that use oxidative phosphorylation, they tend to have a resistance to fatigue resistance. So they don't tend to fatigue very easily, or if at all, most of the time. While this fast to X that tends to be fast, big, and uses glycolysis instead, it actually tends to fatigue a bit. Fatigue prone. And this is a muscle type chart.
Okay, marathon runner will be which type?
Yes.
Which most dominant muscle do they have?
So marathon runners tend to have higher amounts of slow 1A or slow 1. So this is where the marathon runners lie, because they tend to want to use slow acting muscle that keeps on going and doesn't fatigue easily
For hours.
for
Okay.
hours on end.
Could you give me an example of fast 2x?
Yeah, fast to X people would be people like sprinters. They want to use high amounts of energy and speed quickly, and they don't really care if they have to exhaust themselves. They just want to use it really quickly. Another example for those are also Olympic weightlifters and the like. They tend to pull up the muscle and bring it up as fast as possible because they only need to hold it up for a second, unlike marathon runners that need to continually use their muscles for long amount of time. And so now we'll talk about ATP types. So
ATP utilization.
yeah, ATP utilization types. So the first type that we have here is cytosol ATP. So cytosol ATP tends to be kind of a pool of ATP in blood, and it tends to be about 1 to 5 seconds.
Full of ATP inside of cell is
Yeah.
floating around the inside of cytosol.
ATP,
Not in blood.
okay, pool of ATP inside the cell.
Probably
Yeah.
cytoplasm. Okay.
Yeah, cytoplasm, same as the cytosol.
Mm-hmm.
And it tends to act between 1 and 5 seconds, so it's quite fast. While creatine phosphate tends to take about 10 seconds to react, and glycolysis tends to take about a minute to be used. And all of these three require no oxygen. These are completely anaerobic. These don't require any sort of aerobic thing to be used, unlike aerobic respiration, which is what's known as oxidative phosphorylation, or I'll put OP for short. And oxidative phosphorylation or aerobic respiration requires oxygen. And as it requires oxygen, it's also longer. It tends to be over hours of use. Unlike these that tend to be a lot faster, like 1 to 5 seconds, 10 seconds, about a minute.
Okay.
Usage.
Great. Which number is represent the slow type 1?
Slow type 1 would be represented by aerobic respiration. This would be slow 1.
Because
It tends to be used, it allows for use for hours, and it requires oxygen. It does oxidative phosphorylation, which slow 1 does here.
okay, so which type of muscle represents number 3 then?
Number three would be fast 2X. As we can see here, it uses glycolysis. It tends to use it a lot so that we could use that energy really quickly.
Which one will be the things that we can use immediately?
Immediately, that would have to be the cytosol ATP, because it is already in the cell and the cytoplasm as in little pools, and it's able to be used between 1 to 5 seconds quickly. Thank you.